This is lesson 47, solving systems by elimination, day 2. So elimination, we're trying to create opposites. So we already have opposites here with our x's. So 5x minus 5x cancels out. Negative y and 2y makes y. So y equals negative 8 plus 1 is negative 7. So y is negative 7. Now we can plug this into any of those first two equations. We'll use the top one. 5 times x minus y equals negative 8. Substitute in our negative 7. Minus a negative 7 makes plus 7 equals negative 8. Subtract 7. 5x equals negative 15. Divide by 5. And x equals negative 3. So our solution is negative 3, negative 7. Problem 2, we've got a positive negative 4y. 3x minus 2x, x makes x. So x and negative 2 and negative 1 makes negative 3. So x equals negative 3. Let's plug this into the bottom equation. 3 times x plus 4y equals negative 1, and we're substituting in a negative 3. Negative 9 plus 4y equals negative 1. Add 9 to both sides. 4y equals 8. Divide by 4, and y equals 2. So our solution is negative 3, 2. Problem 3. Well, if I multiply this top equation by negative 1, that would make a negative 2x, which is the opposite of 2x. So we'll do that. Negative 1 times negative 2 makes positive 2y, and negative 2. When we add these together, our x's cancel. We get negative 9y plus 2y makes negative 7y. 2 minus 2 is 0. That's fine. Divide by negative 7. 0 divided by anything is 0. That's okay. And now we're plugging in a 0 for y. So we'll use the top equation. 2x minus 2y equals 2. And we're substituting in our 0 for y. So 2 times 0, or negative 2 times 0 is 0. So really this is 2x equals 2, because that becomes 0. Divide by 2, and x equals 1. So our solution is 1, 0. Problem 4, similar. If we multiply by negative 1 here, I'll write it down below. We get negative 9x plus 4y equals negative 15. When we add 2x and negative 9x make negative 7x, our y's cancel, and negative 6 and negative 15 make negative 21. Divide by negative 7, and we get x equals 3. And let's plug it into the second equation. So 2 times x minus 4y equals negative 6. Plugging in our 3, substituting in our 3. 2 times 3 is 6. Minus 4y equals negative 6. If we subtract 6 from both sides, we get negative 4y equals negative 12. Divide by negative 4. And y equals 3. So our solution is 3, 3. Problem 5. If we multiply this top equation by 2, what else could we do? Could we divide the bottom equation by 2 and get a negative 9y? We could do that too. That would make our numbers actually smaller. Let's multiply. 2 times negative 10x makes negative 20x. 2 times 9y makes 18y. And 2 times negative 30 makes negative 60. So now we just have big numbers. We add these together, we get negative 22x. Our y's cancel, equals negative 66. Divide by negative 22. And x equals 3. Let's take the bottom equation here. Negative 2 times x minus 18y equals negative 6. Substituting in our 3 for x. So negative 6 minus 18y equals negative 6. If we add 6 to both sides, negative 18y equals 0. What's that mean? Y must equal 0. So our solution is 3, 0. Problem 6. If we multiplied this bottom equation by 2, right, we'd get negative 2x minus 18y equals 6. And so now we're going to add these two together. Alright, so 2x minus 2x is 0. Negative 2y minus 18y makes negative 20y. And 14 and 6 make 20. So we divide by negative 20. And so y is negative 1. And let's substitute this into this top equation. So 2 times x minus 2 times y equals 14. And we're substituting in a negative 1 for y. So we get negative 2 minus 2y equals 14. Add 2 to both sides. Negative 2y equals 16. Divide by negative 2, and y equals negative 8. Our solution is negative 1, negative 8. Problem 7. If we multiply this bottom equation by negative 3, we'll get negative 3x plus 9y equals negative 45. And now we'll add our top two equations together. The x's go away. 9y minus 7y makes 2y. And negative 45 and 29. Well, we need to borrow, what is that, 16? Negative 16? Negative 16. Divide by 2, and we get y equals negative 8. And we can substitute that into any equation. Let's use this bottom one. So x minus 3 times y equals 15. And we're substituting in our negative 8. So x plus 24 equals 15. Subtract 24. And x equals, what's that make? Negative 9. So our solution is negative 9, negative 8. Problem 8. If we multiply this bottom equation by negative 2 again, we'll get positive 10x. We'll get negative 6y, and we'll get negative 12. When we add these together, that cancels. Whoa. Our y's cancel, and our constants cancel. So we get 0 equals 0. If we get something that makes sense, what's our answer? We must be talking about the same equation. Let me show you this a different way. So if we have the same equation, then we have infinite solutions. And let me prove to you that this is the same equation. If we were to multiply this bottom equation by 2, what would we get? We get negative 10x plus 6y equals 12. Isn't that the same as what we have up top? So it's the same equation twice. Infinite solutions. Our word problem is right here. Looks like my RAM must be getting a little low. Sporting goods store sells right and left-handed baseball gloves. In 1 month, 12 gloves were sold for a total of $561. Right-handed gloves cost $45. We're going to say right-handed gloves are going to be X. Alright, so right-handed gloves are X. And they cost $45. And left-handed gloves, we'll say those are Y. And they cost $52. So what do we have if we sold 12 gloves in a month, right? We're selling X plus Y equals, oops, not 52, x plus y equals 12, right? And now how much was a right-handed glove? Was $45. So that's 45 times x, plus how much was a left-handed glove? Was $52, so that's 52y. And how much did we sell total? Was 561, so equals 561. So solve this using using elimination. Let's divide. Let's multiply this entire equation by 45, by negative 45. Negative 45. So we get negative 45x minus 45y equals, that equals negative 540. So when we add these together, our x's cancel. We get 7y equals 21. Divide by 7. And y equals 3. So we sold 3 left-handed gloves. And if we sold 12 gloves total, how many right-handed gloves would that make? Wouldn't that make 9 right-handed gloves?